Copyright 2015, Math, Diagnostics, and Intervention, all rights reserved. We're going to take a look at teaching the addition algorithm. And one of the things to keep in mind about the addition algorithm is that the goal of the addition algorithm is to be able to have students eventually add polynomials like the ones we have here. And if we're teaching an algorithm that doesn't get us to this point, we're probably not doing the students any favors. So let's take a look at some traditional arithmetic problems involving addition. Let's start off with the way we normally teach 36 plus 27. The way this is traditionally taught is we tell students, well, that's 7 plus 6 is 13. That's 3 carry 1. And then 1 plus 3 is 4, and 4 plus 2 is 6. So we end up with a final answer of 63. The problem with this method is that it doesn't get us to this. It doesn't get us to polynomial addition. So the way I prefer to teach this, and again, getting students to get to this algorithm may well be worthwhile eventually, but to start this as a teaching point, as the first way students see the addition algorithm, is probably a mistake. The way I would prefer to see students learn this, and the way I teach this, is that 7 plus 6 is 13. 30 plus 20 is 50, and then we have 3 plus 0 is 3, 10 plus 50 is 60, and we end up with a final answer of 63. The advantage of this is that we end up teaching students that we add like terms to like terms. And we have the tens place all added together, and we emphasize the place value of these terms by saying 30 plus 20 rather than 3 plus 2. This, again, may not look like it's going to help us get to here, but it does. Let's take a look at a slightly more complicated problem and look at it from a more advanced standpoint. Let's look at $143 plus 236. And I'm going to write these numbers out in expanded form. What this becomes is 1 times 10 squared plus 4 times 10 to the first plus 3 times 10 to the 0. And then we're going to add that to 2 times 10 squared plus 3 times 10 to the first plus 6 times 10 to the 0. And then we add our like powers together. So I have the 1 times 10 squared and the 2 times 10 squared. That's a total of 3 times 10 squared. And then I also have the 4 times 10 to the first and the 3 times 10 to the first. So that's going to become plus 7 times 10 to the first. And then we also have the 3 times 10 to the 0 plus 6 times 10 to the 0. That gets us plus 9 times 10 to the 0. So our final answer becomes 379. Of course, you'd never teach a second grader how to do this way, and this is a vastly more advanced way to teach addition or to use addition. But this does get us to our final goal at the very top here, where we can now add our like terms. We can add our second degrees, our first degrees, and our 0 degrees together in order to get an answer. Now, that was a simplified answer, but let's take a look at something that's a slightly more complicated that involves carrying, as we sometimes call it, regrouping. Let's take a look at 386, and we're going to add that to 491. And we end up with 3 times 10 squared plus 8 times 10 to the first plus 6 times 10 to the 0. and we're going to add that to 4 times 10 squared plus 9 times 10 to the first plus 1 times 10 to the 0. Adding our like terms together, we end up with 7 times 10 squared plus 17 times 10 to the first plus 7 times 10 to the 0. Now, if we were adding or just polynomials, this would be a perfectly acceptable answer. The problem is that if we try to put this back together again as a single integer, we end up with 717 tens and 7 ones. And we have no way in our positional number system to represent 17 as a single digit in the tens place. So we can't do that. So what's really going on here? Well, we've got 7 times 10 squared plus 10 plus 7 times 10 to the first plus 7 times 10 to the 0. We're going to distribute our 10 to the first in. We get 7 times 10 squared plus 10 to the first times 10 to the first plus 7 times 10 to the first plus 7 times 10 to the 0. This is really 10 to the second. Our 10 to the first times 10 to the first is really 10 to the second. So we've got plus 1 times 10 squared plus 7 times 10 to the first plus 7 times 10 to the 0. And we end up with 8 times 10 squared plus 7 times 10 to the first plus 7 times 10 to the 0. So that's how you end up regrouping or carrying from an algebraic or power perspective. Now, how does that help us with this? Oh, we just did this. This problem is 386 plus 491 in expanded notation. And that's exactly what we did right down here. 386 plus 491 in expanded notation. Only with the polynomials, we don't have to regroup our 17x. Our final answer would be 7x squared plus 17x plus 7, and we're done. I hope this helps you to understand a better way to teach the addition algorithm, and I wish you good luck.